Let's just spend a minute or so on the ROC graph before moving forward. A ROC curve is a graph showing the performance of a classification model, and the area under its curve is a measure of the accuracy of a model. This metric varies between 0 and 1, and the closer to 1 it is, the better our model is able to predict. Underneath our graph, there are two options to view the test set metrics or the validation metrics. We are going to stick with the results of the graph for the validation metrics. On the ROC curve, we can see three circles: best F1, best MCC, and best AUC. If I hover over the best AUC circle, I am able to see a pop-up window of a confusion matrix, which shows how many predictions are correct and incorrect per class in comparison to what the actual credit score values were. On the principal diagonal, I have yellow values representing the total number of around 13,000 good credit scores, which are correctly predicted as being good. Additionally, we have a total number of around 5,000 bad or poor credit scores, which were correctly predicted as being bad or poor. Overall, our best model does a good job, as it accurately predicts around 90% of the credit scores. Depending on your business case, you might want to take a look at the values from the secondary diagonal and further learn why in almost 10% of the cases, our final model was not able to predict well. Might it be that some of the observations are too heterogeneous with respect to the majority and need particular attention? And if this is the case, do we need to eliminate them from our dataset or treat them separately? What is more important to my business case? To have less prediction errors on the good credit score or have less prediction errors on the bad one? These are just a couple of questions that you might want to ask yourself.